So we've looked at the two paradoxes which explore what happens if time and space are viewed as infinitely divisible, namely the dichotomy in Achilles and the tortoise. In fact, the third paradox that Aristotle mentions in the Physics is the arrow, but I'm actually going to leave that one till last for reasons that I hope will become clear. Next, we're going to look at the moving rows. Now, Zeno says imagine 3 rows of 4 equally sized bodies. The first row of 4 bodies, that row is the A's. The second row is the B's, and the third row is the C's. The first row, the A's, this row is stationary. The B's and the C's are moving in opposite directions past the A's at equal speeds. Zeno claims from this paradox he can show that half the time is equal to its double. Sounds baffling. Aristotle is very dismissive of this. He says, oh, Zeno's made a really elementary mistake. Zeno has assumed that bodies moving past a stationary body and also another moving body of equal size will take the same amount of time to move past the stationary body and the moving body, but of course this is false. So Aristotle says that Zeno has made a really elementary mistake and that this paradox is just not interesting. But supposing that these equal bodies are supposed to represent indivisible minima of space, indivisible chunks of space, if you like. And so you've got the 4 A's, the 4 B's, and the 4 C's. They all represent indivisible chunks of space. And supposing you've got your stationary A's and the moving B's. Supposing one moving B moves past one stationary A in one indivisible quantum of time, in one indivisible minimum of time, atom of time, if you like. So we've got an atomic theory. And supposing that in that one indivisible quantum of time, this moving B has passed 2 C's, which are moving, if you recall, in the opposite direction. So in the same indivisible chunk of time, the same quantum of time, the B has passed both one stationary A and 2 C's. That seems natural enough, and that of course takes into account what Aristotle wants Zeno to take into account, that a body is going to move past a stationary body more slowly than it's going to move past another moving body. Okay, no problem there. But imagine how long it takes this moving B, this indivisible atom, to pass one moving C, not 2, but 1. Okay, and then supposing Zeno were to say, how many A's has this moving B passed in the time it takes to move past 1 C? Now we want to say half an A, because that would appear to follow, but there is no half an A. A is already the smallest possible unit of space, so the smallest possible chunk of space, an atom of space. It can't move past half an A, it can only move past 1 A. So in the time it takes 1 B to pass 1 stationary A, it has passed both 1 C and 2 C's. So you can see why Zeno might think that if you take that reading of time and space, then you can get to this bizarre, apparently absurd conclusion in which half the time is equal to its double. So we have a real problem here, a real problem. And this makes it look as if this way of viewing time and space, this atomic theory of time and space divided into indivisible minima, is just not going to work. So it looks as if there's a problem if you view space and time as finitely divisible. What's the option? Infinite divisibility. But then you're back to the dichotomy and Achilles and the tortoise. So do you think that they have raised insoluble problems? Maybe you think, oh, actually that's okay, we solved those problems. It's okay that space and time can be infinitely divisible and Achilles still can overtake the tortoise and the runner still can get to the end of the stadium. So let's junk the notion of time and space as finitely divisible into minima, indivisible quanta, because the moving rose has shown that that is really, really problematic. Let's return to this notion of time and space as infinitely divisible, like we saw with the dichotomy and Achilles and the tortoise. Maybe that's fine, that's fine. But, says Zeno, I've got another card up my peplum, if you like, my Greek equivalent of a toga, because I'm going to give you the arrow and I'm going to show you that time and space are really problematic, whether you view them as either finitely or infinitely divisible. So now we need to look at possibly the most complicated of all Zeno's paradoxes, the most challenging, the one that mathematicians and physicists still write about, and that's the arrow.